Hello students, welcome to Chem Expert classes. I hope you all are doing fine. Today we are starting with mole concept. This is a very important concept from your exam point of view, and I have heard that many students are having very serious problem with understanding this concept. So we are starting with this. So what is mole? Mole is basically just a number. Yes. Okay, it is just a number, nothing to worry, guys. It is just a number. We are just going to discuss some amazing tricks in order for you to understand all the numericals and every concept of this particular topic. Okay, so whenever somebody says that they have 1 dozen of bananas, right? What do you understand from that? You understand that they have 12 bananas, right? Correct? So whenever somebody is saying dozen, you understand 12. When suppose I say one pair of shoes, right? What do you get from this? You get 2 shoes. Correct? So the word dozen is associated with the number 12. The word pair is associated with the number 2. Similarly, the word mole is associated with one number, and that number is known as Avogadro's number. Okay, and that Avogadro number, my friend, is 6.022 into 10 raised to the power 23. Okay, so when I say I have 1 mole of a particular thing, I mean to say that I have 6.022 into 10 raised to the power 23 particles of that particular thing, right? And these particles can be anything. They can be atoms, they can be molecules, electrons, protons, neutrons, or any kind of particle. Okay, so whenever I am saying I have 1 mole of an atom, I mean to say I have 6.022 into 10 raised to the power 23 particles of atom. When I say I have 1 mole of molecule, then again I mean to say that I have 6.022 into 10 raised to the power 23 particles. Right? Are you getting it? So 1 mole is associated with one particular number, and that number is known as Avogadro's number. I hope this particular thing is clear to you. Now we before moving further with the numericals, we are going to just understand a few definitions which are very important. Okay. The first definition we are going to discuss is the atomic mass. So atomic mass of an element is the relative mass of its atom as compared with the mass of the carbon-12 atom, right? First, we are going to discuss a very simple definition, which is atomic mass is the mass of an atom, right? The mass of one atom is known as atomic mass. Now, atomic mass is always calculated in comparison to carbon-12 atom. Okay, so 1 AMU is nothing, 1 atomic mass unit is nothing but 1/12 of carbon-12 atom. Alright, so what it is basically is the mass of one atom. That is why the name atomic mass, right? So the unit, SI unit of this is AMU, atomic mass unit, or it can be written as U. Alright, so if I am talking about hydrogen atom, then I say the mass of atomic mass of hydrogen is 1U. If I talk about carbon, I say the atomic mass is 12U. If I talk about nitrogen, I say the mass is 14U. So the unit is U and the mass is 12. Alright, so I hope this is clear. It is the mass of one particular atom. Right, now we are going to discuss gram atomic mass. Now gram atomic mass is the mass of 1 mole of atoms, right? 1 mole of atom. Atomic mass was a mass of 1 atom. Gram atomic mass is the mass of 1 mole of atom. That means 6.022 into 10 raised to the power 23 atoms. The mass of these many atoms is going to give us gram atomic mass. Okay, now the SI unit for this one is grams. Alright, so if I say hydrogen has atomic mass of 1U, it has gram atomic mass of 1 gram. I say oxygen has atomic mass of 16U, then it has gram atomic mass of 16 gram. Carbon has atomic mass of 12U. Carbon has gram atomic mass of 12 gram. We just replace U with G. That's about it. So what we have learned so far is that atomic mass is the mass of one atom, whereas gram atomic mass is the mass of 6.022 into 10 raised to the power 23 atoms, or 1 mole of that particular atom. I hope it is clear. Now we are going to discuss the next definition, which is molecular mass. So as the name suggests, molecular mass is the mass of one molecule. It is similar to the atomic mass, but the only thing is that here we are calculating the mass of one molecule, right? Mass of one molecule is known as molecular mass. For example, if we are talking about O2, oxygen gas. So the atomic molecular mass of this is going to be O plus O, which is 16 plus 16U, which is going to be 32U. Right? Now, if we are calculating for water molecule, it is going to be the atomic masses of all the atoms, right? So for hydrogen, 1U, another hydrogen, another U, and for oxygen, 16U, it is going to be 18U. So this is what is atomic mass. So 18U is the mass of one molecule of water. Now the next definition we have is the gram molecular mass. So the gram molecular mass is the mass of one mole of the molecule, right? That means Avogadro number of molecules. So if I am saying that water is having 18U molecular mass, then it is going to have 18 gram of gram molecular mass. I hope this is clear to you. You just have to replace G with U. That's about it. Now we are going to discuss the numericals based on this concept. So here is the mind map given to you. So first we are going to understand this. What this means is that 1 mole of any substance is going to have Avogadro number of that particular substance. 1 mole of that substance is going to have gram atomic or gram molecular mass of that particular substance, right? And Avogadro number of that substance is going to have the gram atomic mass of that particular substance. So what I mean to say by this is that if I say I have 1 mole of oxygen, what I mean to say, what that also can conclude is that I am having 16 grams of oxygen atom. If I say I am having 16 gram of oxygen atom, it also means that there are 6.022 into 10 raised to the power 23 particles or atoms, right? Which means we have 1 mole of oxygen. Right? So 1 mole of any particular substance is going to have Avogadro number of particle and is going to have the gram atomic or the gram molecular mass. Alright? Now this will become more clear when we discuss the numericals. Here is our first numerical. So, how many moles are there in 5 gram of calcium? You have to calculate the number of moles present in 5 grams of calcium. So, here is the trick, guys. What you have to do is, whatever you are asked to calculate, you have to keep that thing on the right hand side, and whatever you are given with, you have to keep it on left hand side. So, here you have to calculate number of moles of calcium, right? So, keep it on right hand side, and what is given to you is gram atomic mass of calcium, right? Keep it on left hand side. This is your rough work. This is going to be a rough work. Now what you have to do is you have to just write down the gram atomic mass of calcium and how many number of moles it will have. So what I am trying to say over here is 40 grams of calcium is going to have, or you can write, will have how many moles? 1 mole, right? 1 mole of calcium. Now you are going to use unitary method, which is 1 gram of calcium will have 1 upon 40 moles of calcium. Now 5 grams of calcium will have 1 upon 40 into 5 moles, right? Which is going to be equal to 1 upon 8 moles, which is going to be equal to 0.125 moles of calcium. I hope this is clear. There is only one trick. What you have to do is whatever is asked from you, you have to keep it on right hand side, and whatever information is given to you, just keep it on left hand side. Based on this particular trick, we are going to solve another question. Okay. Now this one, second question. How many moles are 9.033 into 10 raised to the power 24 atoms of helium? Okay. Now just keep in mind, you have to keep whatever is calculated is to be calculated on the right hand side. So you have to calculate number of moles of helium. And what is given to you? Number of atoms. So number of atoms of helium. Now write whatever you know. Right? How many number of atoms you know? You know Avogadro numbers. 6.022 into 10 raised to power 23. How many moles? 1 mole. 1 mole of helium. So that means 6.022 into 10 raised to power 23 atoms of helium will contain 1 mole of helium. Now you will use unitary method. So 1 atom of helium will have 1 upon 6.022 into 10 raised to power 23 moles of helium. Similarly, 9.033 into 10 raised to the power 24 atoms will have 1 upon 6.022 into 10 raised to the power 23 into 9.033 into 10 raised to the power 23 moles, which if you calculate is going to come out to be 15 moles. Okay, so this is 15 moles of helium. Now here is another question for you guys. Calculate the number of iron atoms in the piece of iron weighing 0.8 grams. Now again do the same trick. What you have to calculate is number of iron atoms. So number of iron atoms. And what is given is the gram atomic mass of iron. Right? So now we are going to write whatever we know. So gram atomic mass is 56 gram of iron will have how many number of atoms? 6.022 into 10 raised to the power 23 atoms of iron. So 1 gram of iron is going to have 6.022 into 10 raised to the power 23 by 56 atoms of iron, and then 2.8 gram of iron will have 6.022 into 10 raised to the power 23 by 56 into 2.8 atoms, right? Which you calculate and you will get 3.011 into 10 raised to the power 22 atoms of iron. I hope this is clear. We are done for today. I hope you have understood the session very well. If you have any kinds of question, queries or doubts, you can keep it in the comment section. You can comment below. If you have liked everything, you have understood my explanation, what you have to do is you have to like the video and subscribe to my channel so that I can reach more and more students. Thank you so much. Have a great day. Bye-bye.